Okay, so this is lab 4.4. The purpose of the lab today is to test the effect of temperature on the solubility of two different substances. So in other words, we're going to saturate two solutions at room temperature. We're going to record the solubility at room temperature, at least in terms of how soluble it appears to be, because we're not actually going to collect quantitative data for this one. It's purely qualitative, which does make it a little bit easier. So we're going to saturate two solutions at room temperature, note how soluble they appear to be at room temperature, then we're going to heat them up, and we're going to note how the temperature, the heating up, affects the solubility, if at all. Then, once we've noted that, we're going to cool them back down to room temperature and see what happens. So what I decided to do is go ahead and get a little bit ahead of the game. So here I have the two solutions, the saturated solutions at room temperature. This is substance B. You can see that. Substance B. There it is. And this one is substance A. And as you can tell, I've already mixed these up and given them sufficient time to dissolve. Neither one of these is actually all that soluble. And let me backpedal a second. For those of you that missed the lab entirely, each test tube has 10 cubic centimeters of water and then 10 grams of the given substance. So this one has 10 grams of B, this one has 10 grams of A. And then we, instead of putting the stoppers on and mixing them, we simply used a stirring rod, which we're going to use while we heat it. So we used a stirring rod to heat it up. And this is what we observe at room temperature. And in terms of data, I would simply state that neither substance appears to be very soluble at room temperature. Okay, so that's the first part. Now, normally I would take these and put them right into the hot water on the hot plate. But I went ahead and already heated these solutions in the interest of time to make this video a little bit shorter. So here we have, and I'll bend that a little bit so we can see. Okay, so we have the hot plate. We have our two substances in a beaker of hot water. And what you all would do if you were in class is to mix these continuously for a few minutes and then to observe the apparent solubility of each of the substances. Okay, so this has already done what it's supposed to do. This part of the lab would take probably about 10 minutes. So the second part is taking the two saturated solutions, putting them in a beaker of water, heating it up, stirring continuously until one of the substances dissolved. So what we can see now, and these are hot. Actually, let me do this. Let me scooch this over here again. Okay, and put that back. All right, so here's what happens. Here's substance B once it's heated. Kind of hot. It's completely, utterly, totally, thoroughly dissolved. Those little bubbles you see in there are just water. I'm trying to get it so you can totally see. There's not one little drop of substance left over. So let's compare that to how it looked before. So here's substance B at room temperature, and here's substance B once we heated it. So very clearly it's obvious that substance B is affected by temperature, at least the solubility of substance B. So let me say that again. The solubility of substance B is affected by temperature, in that as the solution is heated, it becomes more soluble. So all of this is now completely dissolved. And this is what it looked like before. Substance A, on the other hand, not so much. It pretty much looks just as it did. Let me put that down for a second. Pretty much looks, this is before. This is substance A before. This is substance A after. Just from looking at it, it's very difficult to tell if any of it dissolved. I would probably write in my lab notes that substance A was not affected by the heat. So the solubility of substance A does not appear to be affected by the heat. It appears that no more of it dissolved when it was hot than when it was at room temperature. All right, so now we're going to cool it back down to room temperature. And this is where it's really cool. So this is substance B, still totally dissolved. Substance A, not so much. I'm going to put it at room temperature, and I'm going to try to hold this so you can watch what happens to substance B. Hopefully this doesn't take too long, but let's watch what happens to substance B as we let it cool back down again. right now, nothing. Usually this happens a little bit faster. I could mix it to help it along, but it actually looks a lot cooler if I don't heat it, if I don't mix it, I mean. So we'll be patient. Sirens. Come on, substance B. Maybe I heated it too. I heated it quite a while. Maybe that's the problem. Well, this is kind of uneventful, isn't it? I wonder if in my preparation I heated it longer, so it's going to take a little bit longer for us to get what we're supposed to get. All right, let me do this real quick. Since nothing really interesting is happening at the moment. Oh, wait, there it goes, there it goes, there it goes. Be patient, right? Patience is a virtue, that's what they say. I don't know if you guys can see that. Watch what's happening to it. I'm going to shake it a little bit. There it goes. There it goes. Do you see it coming back out of the solution? A crystal is forming at the bottom. We call that a precipitate. Looks so cool. It's not as easy to see with the camera than in real life. If you're looking at this in the lab, it looks way cooler than what you can see on the camera right now. But basically, as the temperature cools back down again, all of that stuff that had dissolved is coming right back out. You see it floating around in there? There we go. And it actually looks kind of crystalline. Looks like it's crystallizing. We actually call that a precipitate. So the idea is this. Substance B at room temperature is not that soluble. We heat it, and it all completely dissolves. So we know right off the bat that the solubility of B, substance B, in water is highly affected by temperature, and that all of substance B is going to dissolve once it's heated up. Then when we cool it back down again, back to room temperature, all of that stuff comes right back out of the solution. See, look how much is there. If we look and compare it back to the other one that we did not heat, this one was unheated. Pretty much this is the same amount that was undissolved to begin with, comes back out of the solution. We call that a precipitate. So it's kind of more impressive live in real life. I'm watching it on the camera and it doesn't appear to be as cool as what it looks like for real. But if you missed the lab and you weren't able to be here, this is probably as good as it's going to get. So again, this is substance B prior to being heated. Not much dissolves, if any. When we heated it in this test tube a minute ago, you could see that was completely and totally and thoroughly dissolved. There wasn't any bit of solute left out of solution, so it completely dissolved when we heated it. We let it cool back down again, and every last bit came back. See, same amount as what we started with. Pretty cool. So that's this lab. Very straightforward. Nothing tricky to it. Nothing quantitative, which is kind of nice for a change, that we don't have to quantify all of our learning. Qualitative observations are sufficient for this one. So substance A, the solubility of substance A did not appear to be impacted at all by the heat. It was not very soluble at room temperature, not very soluble when heated, and therefore when we brought it back to room temperature, again, no major changes. Substance B, on the other hand, the solubility of substance B was not so great at room temperature, but the solubility was highly impacted when we heated it. So all of the substance dissolved once it was heated. We cooled it back down, and all of it came right back out of the solution again. So that's our lab, and we'll do post-lab tomorrow, and then there will be pencast notes to follow that up. Hopefully all of this made sense, and you got something out of it. Thanks. Bye.